Today's world is not only facing heart disorders or internal diseases, but also the physical strain like spondylitis, back pain, arthritis, osteoarthritis are also joining the race. In order to deal with the recent problems, here our technical approach is joining hands in hands with the medical world to serve the humanity.
The main aim of the project is to design an intelligent device for patients suffering from the arthritis or any other neurological disorders to help them in day-to-day normal activities.
Flex sensors, which with variation through bend or in angle produce different resistance values, which in turn convert into electrical signals. Set of analog values obtained from the flex sensors are sent into microcontroller MSP430F5529, which is the heart of our project. And MSP430F5529 is driven by a power supply from the USB of the laptop, and the signals are then converted from analog to digital form in order to drive the servo. In this project also, we are using HCSRO4 as an ultrasonic distance sensor for measuring the distance between the obstacle and the knee joint in order to produce the action by a servo motor.
Flex sensors are passive resistive devices that can be used to detect bending or flexing. This is an analog device whose value ranges from 0 to 1023 on bending.
For the flex sensor, and yet this whole thing acts as a voltage divider by which we can obtain VO1 according to this equation through an op-amp, which is acting in voltage follower closed loop condition. And as we know that gain of an voltage follower is unity, so we can obtain VO1 and VO2, and we can use it for our applications or for measuring the analog values.
The diagrammatic representation here represents the dominance of flex sensors in present-day market. The main reason for this dominance is that flex sensors can withstand temperatures from -35 degrees to 80 degrees Celsius.
This is the MSP430F5529 evaluation module. As you can see, it has a SD card interface which is of 2 GB capacity. We have a 102x64 dot matrix LCD, a 3-axis accelerometer which is over here. We have a 5-pad capacitive touch slider, analog thumb wheel. These are used for JTAG pin, these tools. This is the 5529 USB port and one more EZ FET USB port.
This is a differential amplifier. Here we are using LMH6882SQ, which is an op-amp, and we are giving an input to the non-inverting terminal, and which is acting as a voltage follower. In this case we are using 2 op-amps, and there is a resistors connection which we are given, and to this we are the output of each terminal has been given to another op-amp, by which again we are obtaining Vout or the output of the circuit. And by solving these equations, we will obtain R4 by R2 into V2 minus V1. We are using this type of circuit because in inverting amplifier we have low input impedance, and in non-inverting amplifier we have high input impedance. For the impedance matching, we use this type of circuit, which is a differential amplifier.
Servos are small mechanical devices whose sole purpose is to rotate the tiny shaft extending from the top of the servo housing. Each servo has a built-in processor that responds to the electrical pulses sent to it. The duration of these pulses are known as pulse widths. Servos interpret these pulse widths as positions. Each position along the arc traced out by the rotating shaft has a corresponding pulse width. When we send a pulse to the servo, the control board calculates which way the shaft should rotate.
The circuit is the basic representation of how our working model is going to be. As you can see, this is the flex sensor, and as per the change in bend or the change in angle, the variation in servo motor can be experienced. And this part is the circuit of the flex sensor which we need to control, and this is the servo 430 F5529 microcontroller, from where all the circuitry and the connections have been performed over the time. And this is HCSR4, which we are using as an ultrasonic distance sensor, and the power supply we are providing as of now from a 9-volt battery.
Now the flex sensor bends. When we bend the leg, the flex sensor also bends, according to which the servo is rotating.
So the final prototype has been implemented on the subject, and we will soon be demonstrating the intelligent.
I'm pretty comfortable. Let's start.
With the bend of the knee, the flex sensor is actually able to drive the servo motor, and the leg is moving automatically. So Anirudh, how does it feel?
Since I do not have to put any effort to move my leg, and it's very comfortable, I think the functioning of the equipment is perfect.
This position, Anirudh is actually trying to climb up to another level. At this angle, the flex sensor will be automatically driving the thigh.
Graph shows the number of people aged 18 or above with osteoarthritis per 1,000 people in different parts of the world. The situation is alarming all over the world, more so in America and Asia, thus proving that an innovation like ours is the need of the hour. Of late, tissue engineering techniques have come up to deal with knee and joint problems, etc. But these methods are very expensive and complicated. Our proposed idea would present a simple solution to these problems with an inexpensive and simple approach.